So at this point on this FPGA dev board, this is again for this BGA-121 package of an iCE40 that I'm trying to get going. The first step was to get really the power portion of this filled in, and I'm using an LT3504 regulator, and that has 4 outputs. And so I've got a 5 volt, a 1, 2, a 2, 5, and a 3, 3. And since the last video, what I've done real quickly is I've come in here and let me just zoom into this. But I have added a little transistor down here so that I can actually show if the 1.2 voltage is running. And so you'll see this light up if 1.2, if that rail is going. I previously had an LED that was working for the 5 volt, 3 volt, and 2 5 volt. So you'll see a bright red, a little bit dimmer, and a little bit dimmer as you go through those 3. But then this 1.2, because of the transistor, I'm pulling it from a 5 volt, so that'll be a nice bright LED. And I've also come over here and wired up the power good LED. So there's a blue LED that you'll see that lights up when power is good. And for the power good, I'm pulling from a 5 volt, and I just tapped in over here. So you'll see these little wires, these little bodge wires, since I didn't have that in my schematic quite right. And same with down here. I had to pull in the 5 volt to drive the LED, but the transistor is signaling off of the 1.2 volt. So if I turn this on, right now I'm running 9 volt out of my power supply for my bench top. And it's coming into here with 9 volt. And when I flip this switch, basically that's going to now come into the regulator. And I can see I've got my blue power good. I have these 3 LEDs showing me that I have my 5, my 3.3, my 2.5. And then with the transistor, I'm also seeing this 1.2. So that all looks good. But I thought what might be good now is to start putting a load on this. And I started to do that, and I am having problems. So in this specific video, I'm maybe not going to troubleshoot this a whole lot, but I'll just show what I'm seeing, and then in a follow-up video I'll do some troubleshooting, and maybe I'll comment here in a bit on some of the things I think I'm going to have to look at as I troubleshoot this. But I'm going to start out here, and on my screen I'm recording 2 things. My digital multimeter output, and you're seeing that in the upper right, and also an oscilloscope output. So I have, if I back up here, I have an oscilloscope that I can plug in, and then I have some basically leads that I can read from my digital multimeter. And so it seems like, one of the first things I'd want to do is just see what the voltages are out of my 4 rails. Now those are completely adjustable, and I have resistors over here, and looking at that a little bit closer, there's resistors over here that allow me to adjust what is the power output. And I didn't have resistors with the exact values I was looking for, so I grabbed the closest thing, and I have some more dialing in to do there, so I'm going to have to order some resistors in some different values that I'm looking for. I think in a future version, if I am going to continue with this LT3504, I might add in 4 little potentiometers that can work with these resistors so that I can dial things in and not have to change resistors. For example, if I need a 30 kilo ohm resistor, maybe I would put in a 27 or 28 kilo ohm and then put in a 5K pot. And that way I could, if my target's 30, I could go all the way from 27.5 up to 32.5 as an example, and really see what it looks like. But maybe for now, I'm just going to grab ground, and I'll pick just down here so it's out of the camera's way. But if I come in and I grab this header, this should be my 1.2 volt. And you can see I'm reading 1.1965 for the voltage there. And if I come over to the 5 volt, I'm getting a 4.918. So that's when I probably need to bring up the voltage a little bit. And that will require a slight resistor change to do that. If I come up here, this is my 2.5. And I'm getting 2.5469. Again, I could maybe try to dial that down a little bit, but that's close enough. And that's a rail that I probably will never use anyway, so I will probably leave that one alone. And then over here is my 3.3. and I'm at 3.1943. So I'm shy on that one. Again, a little resistor dial in. I should be able to get that up to 3 correctly. So my 1.2, I'm good with that. My 5 is a little shy. I want to bring that up. And my 3.3 is a little shy, so I want to bring that up. So I have some resistors to order to do that for those two, and I'll adjust these down here accordingly. Now, of course, I can grab a closer ground to this space up here if I want, or I could even go across, say, between this resistor or this capacitor here, and be really close. And that's, again, 1.1965. I could do the same over here. I could take the ground side. This is the closest ground. And I could read out what is my voltage on my 5 side of things. And let's see. Okay, 4.198, and if I come up here, oops. Yeah, so that reads the same, 4.198. So I'm getting the right voltages out of all of those. Now, if I grab my scope for a second, and I'm just going to plug in, I just soldered 3 pins on each of these pads, basically, to give me something to hook up to that's relatively close for oscilloscope. Now, I know at this point, especially for some of these frequencies, even this little fly wire is not the way to do it, and I should get that little coil adapter that goes at the tip here. But for now, that's not what I'm doing. If I come down to this and I look at one of the frequencies here, let me see if that's showing up. I need to have my scope refresh here. But if I want, I can look at this frequency that I'm running at, and that's a 942 kilohertz. So I'm not quite at a megahertz for the frequency on this converter, this buck converter or iCE regulator. But again, that's a slight resistor change. I didn't have the exact value I needed, and I'm using one that's close. So between a megahertz down to 942 kilohertz, I don't think that's going to make a difference. Now, what that wave should look like here, I'm sure I have work to improve that, but that's what you see here is what's coming out of that at the moment. And if I go over to my schematic for a second, and I look at that, I am up here focused on this LT3504, and SW5 is this upper one that I was just reading, that frequency. So basically coming out of that, what frequency is it using? And basically that's, I think, boosting the power so that it can generate the rest of these rails. But that's what I'm reading there. Now, if I use my scope and I read out some of these other values, coming back here, again, here is my 5 volt. And I can see what that looks like. Let me pull this down. Oops, actually up. Okay, I'll go about there. So I can see kind of where I'm at if I hold this pin still. And if I look at the 5 volt, that's what that looks like at the moment. And if I go over to my 1.2 volts, and if I go to my 2.5, and then my 3.3, so nothing there seems terrible. But what I now want to do is actually put a load on this. And so I'm going to turn it off for a second. And so to put a load on this, a few things that I have at my disposal is, first of all, I just have some good old resistors. These are 10 ohm, 10 watt resistors. So I suppose I could just simply get some of these connected to one of the rails and draw some current with those. So I can use these if I choose to do so. Maybe another option I have is to use something like this or something like this. And basically what you're going to see here is this is a small little, well, I don't know, little PCB that puts a load. And I can connect up to one of the rails with a couple of wires and then adjust how much of a load I want to pull. And that might be one way that I could test some of these rails. And I've got a pair of those so that I can maybe test two of the rails, like the 3.3 and the 5 volt maybe are the two rails that I would test with that. Again, I'm not so worried about the 2.5 other than maybe I just want to test it. And then I have one more of these, and this is really the same concept as these two. The difference, though, is these two can't go down and put a load on a 1.2 volt output. They only go down to 1.5, whereas this one will go down to 1.0 volts. So if I want to put a load on the 1.2 rail, I'll use this little guy. And if I want to put a load on the 3.3 and the 5 volts, I can use these two. And I can have all three of those running simultaneously. And if I wanted to also test the 2.5, maybe I would use those resistors or something else to generate a load there. But I've run into a problem before that. And maybe I'll start with, I'm just going to grab one of these. I'll grab this one right here. So if I can get this all in the camera view, I'm running, again, 9 volts to this, coming in through the regulator, and then I've got these rails. And I'm going to go ahead and connect this to the 5 volt. And so I'm just going to tap into the 5 volt header there. And maybe I'll actually even start with the 3.3 volt. So here's my 3.3 volt and a ground. So here's the closest ground that I can easily connect to. And this little unit takes USB for power. So I'll just come down and plug in some power for that and turn power on. And now I can go ahead and adjust on this little screen here what I want to do. And so there's some protection settings that I can put in here. If I actually hold down this little set for a second, and I see I've got to kind of angle it for this to show up okay with the glare. But I can select a low voltage, so at 1.5 volt, that's as low as I can take this. It'll throw an alarm. I can put in the upper voltage, which right now is way up at 23.7 volts for whatever reason. It doesn't matter. It just needs to be above what I'm going to use by a little bit. I can set current protection, etc. So I go through and I set all these temperature protection. And I think this is just corrective voltage, corrective current. If I need to adjust, if I'm actually reading it with a quality meter or something, and this isn't showing exactly the right thing, I'm not worried about the precision at the moment. But what I can do at this point is just simply turn this on. And there's a little potentiometer here that I can turn and adjust how much current. So, I might start by turning this down a bit and just press this button. And at this point, I am getting a low voltage saying, hey, you're underneath the low voltage that we said that we would shoot for, and that's because I haven't turned this on. So I'll turn this on, and then I'll turn on the tester. And I say tester, but basically it's just putting a load on this. And so right now I'm connected to the 3.3 header, which remember was reading 3.2. And it's actually coming in here and reading at 3.3. And that, again, I think is just this isn't calibrated real well. But I can see I'm drawing 0.082 milliamps. And as I turn this, I can just increase that load. And let me see if I can get this. So now I'm at 0.1 and I can work my way up. And as I do that, I can see that the voltage is, maybe dropping and my current is going up. Now, I'm sure there's all kinds of things to say aren't quite right with this test bench, and I understand some of those. these little fly wires probably not the greatest way to tap into this, but I think it's fine for my purposes at least. This little tester is probably not the most wonderful thing in the world, but it's inexpensive. These are sub $20 US, and then this other tester maybe is double that. They're actually a little bit less than that, but maybe $15 and $30. But this lets me quickly put a load on and start to turn this up. And so I can get up here, and maybe at this point I'm pulling 0.5 amps is what this says it's pulling. This is only reading 0.2. And my actual power supply is reading 0.247. Some of that, of course, is being consumed by this little box. But I can start to see that, yes, I am drawing half an amp from my power supply, and this is showing that I'm coming up to, some 0.5 amp here that I'm pulling from the 3.3 volt rail. I did look into actual equipment that does this type of loading, and it is crazy expensive. So I wasn't in the mood to spend thousands of dollars to get a decent, maybe a trustworthy load, DC programmable load appliance or device. So this is what I'm using. Now, at some point, if I turn this up too high, I should trip something. So I'm seeing my voltage continue to drop, 2.97, 2.94. I'm getting up. I'm at 0.7 amps right now, and it's going to keep going. This LT3504 should be able to handle 1 amp. So that's what it's rated at. So I'll just go up to 0.9, and I can see where my voltage drop is at, and some of that's probably just these little wires. But I can see that I'm pulling, this thinks it's pulling that 0.9 amp. So I'd say for that, maybe that isn't so bad. I could, while I've got this load on here, just check and come up here and see what my meter reads. And so it's reading 3.14. So up here, I'm still at 3.14, even though I'm probably dropping a bunch of voltage with these couple of wires coming down to the tester. But 3.1459. So that's what I'm getting for voltage with an amp being drawn from it. So that I'm not going to complain about. Maybe I could also come up here and just look at it on the scope. And that's what I'm seeing on the scope. So, I'm not concerned about this 3.3 volt rail. So that seems okay. But maybe I want to now go check out my 2.5 rail, and it throws the alarm because my voltage dropped. I'm going to turn this off and turn the current way down again. And I'm going to connect to the 2.5 volt. So same drill. I can just slowly turn this up. I'm at 0.2, so there's a 1/4 amp that it thinks it's pulling, and I can just kind of work my way up. If I want to check the 1.2, I'll maybe not use this, and instead, and I'm going to pull this just off to the side a little bit. I'm going to come grab this little unit, and it just takes a separate power, which I'll plug in. And it gives me a little screen that lets me, it shows a battery. That's basically the load, and I can set a couple different displays, but I'll go to this display because that might be most readable on the camera. But it shows what voltage and then what amp bridge. And, I can set all of this. So I can come in here and say, what do I want to set? Right now it's set to 1 amp. That's too high. So I might pull this down to 0.1 amp. That probably does not show up on the camera well, but I'm setting it to 0.1 amp. And voltage low, I'm saying no alarm, just set it to 0 volts. And I'll go ahead and get out of that. But I have a pair of wires here that I can plug in, and I'll grab, just need to grab a ground. And then I'll grab my 1.2 volt, which is right down here. And so, this is still running. I'm still pulling a little bit of current down here. Let's just, no, actually I turned that off. So this one's not running. So I'm not pulling any load with this. And then this right now is not pulling a load, but if I press a button here, it's now on, and it's pulling it's reading 1.12 volts. Again, if I read it up here, I'll probably not necessarily see that. And I'm pulling almost 1/10 of an amp, which is what I had set this to pull. And it's pulling that. And so maybe let me just turn it off, and I'll go and set, and I will set it. Let's go 0.7. I'll do 0.7 amp is what I'm going to set this to. Okay, so that is there, and I'll go ahead and then turn that on. And now it says, well, the voltage dropped according to this. Again, those wires I think are the problem. It says it's pulling 0.7 amps. And I'm going to set that up here. And just simply grab a ground. I'll grab right here, and I'll read the 1.2 rail. And so I'm getting 1.18 volt while I'm drawing 0.7 amps. And again, to me that's not bad. I'm fine with that. But then the challenge I've run into is I'm gonna take this one back off and just pull this off for simplicity for now. But if I come over here and I want to test the 5 volt rail, I can see I'm pulling, it's reading 5 volts here. And I can go to increase this. I'm at 0.15 amps right now. Oh, I take that back. I'm not running. That would be a problem. Let me turn this back down, turn on run. Okay, so I'm at 5 volts, 0.08 amps, and I'm just going to slowly turn that on and bring this up, and I'll see that. But there I just ran into an issue. So let me turn this off, turn it down, and do that again. So it's running, the load is on, and I'm at, as I turn this here a little bit, 0.09, 0.1 amps, and as I go up a little bit, I can see it's just showing a little bit of voltage drop across those wires. But I got to about 0.15, turn that off, about 0.15 amp, and it threw an alarm. And if you watch these LEDs, I'll do that again, turn it back on, and watch the LEDs if the camera will pick them up, but you'll see them show the status of it failing. So 1/10 of an amp. Okay, so what I saw is saw 3 LEDs go out. So I saw the 5 volt go out, I saw the 1.2 go out, and I saw the power good go out. Let me go back and check this on the 3.3 volt again. So if I turn it on the 3.3 volt, 0.6, and I can turn this up, and I'm seeing that get reflected over here. It's changing, and no problem on the 3.3 volt. But when I turn this down and I try to go to the 5 volt, there's an alarm because I lost my voltage. But now when I have this running, I'm drawing a small, see where it's at, 0.06 amps, it's fine. But then as I continue up here, once I hit this, so in that case it was 0.13, 0.14, somewhere in there, it caused an issue. So I have an issue on my 5 volt rail is what it comes down to. Now on my, if I wanted to, I could hook this up to my 5 volt rail. Let's see if I can do this in a way that everything will be visible on the camera. Okay, so I have my scope hooked up, and it shows right now I've got my 5 volt, and I've got all my LEDs lit up. That looks good. Let me go ahead and turn this on and start turning up. So 0.1, 1.3, 1.4, 0.15 is where it failed. Now, maybe what I do on my scope is just set a trigger on that. And let me go do that real quickly. And so I'm going to go ahead and I'm doing edge triggering on that. And I'm going to do a falling. So when this falls below, let's go roughly 4 volts, I want it to stop there, and I'm going to go to normal trigger mode instead of auto. Okay, so with that then, I am running my 5 volts, and I'm going to turn on this load and slowly turn this up 0.1, 0.14, 0.15, and then it triggered at that point. So then I can see on my scope, what it's showing at that point. So I want to zoom out here and repeat that. So that's what I see on the scope then, is that I had my 5 volt and then I dropped down to is that 1 volt. So I went from 5 down to 1, and then it comes back up, of course, because I think this load then is shutting off. It hit its alarm. It hit its, I've got a test that says if it's less than 1.5 volt to basically, reset, and that's what it does. And then the power comes back up. But I'm only getting, again, 0.15 amp or 150 milliamps on my 5 volt rail. So I've got to figure out what might be causing that. Now, real quick, as I think about that, what could that be? So things that come to mind for me, and I definitely am looking for feedback from any of you, but I've found a couple nice docs about troubleshooting these types of regulators. So there's a whole lot of stuff I have to do yet, but it could be something like a soldering issue. Maybe I don't have a great solder connection on the 5 volt related lines, either the 5 volt out or some of these lines that come back in for feedback to regulate that properly. Maybe I have some improperly spec'd components, wrong size inductor, wrong size capacitor somewhere. That could be a problem. It could be the design itself, the way I have it laid out. Something's not happy. So I've got to look at, I'll have to go back and double check all the components I'm using and just read the data sheet and see if the components I'm using should work. Maybe I need a larger inductor. For example, this is a 10 microhenry that I'm using on the 5 volt rail. Maybe that needs to be larger. Maybe the capacitors I'm using, I need to do something different there, or different size capacitors, or something else here. To me, it's probably going to come down to one of 3 things. It's either a soldering issue, which wouldn't surprise me, or it's I have some component specifications that need to be changed in this design, or it's something in the design itself that just fundamentally has issues here. But a few of my rails are working fine, and it's just the 5 volt rail seems to be where I'm running into the issues. So my guess is it's something on the 5 volt. So I've got to just track that all back. I'll double check all the solder connections. I think the 10 microhenry inductor should be fine, but maybe there's a different size capacitor down here I need to work with, or something in the feedback is coming back up. So I'm going to do that offline, and then I'll share another post on what I ultimately tracked down. But I thought some of you might be interested to see, did this work out of the box the way I had it? And I'd say 3 of the rails fine. The 5 volt maybe isn't so critical for this FPGA, but I still want a 5 volt rail in case I run some level shifters to some 5 volt type of signals to 5 volt type of peripherals. So I do want to get that up and running. But that's where I'm at. And if you've got thoughts, discussion, drop a note below in the video. And like I said, as I do troubleshoot this, I will post what I learn as I go.